to the tutorial on Excel Solver. In this video, I will demonstrate how to solve a simple LP model using Solver. So grab a mug of coffee and let us get started. I will begin presenting the structure of this video. First, I will explain the problem that we are going to solve and where you can find the resources needed. Then, I will show how to set up a model, and finally I will solve it. To solve an LP model on Excel, you're going to need two things: the Solver add-in and a spreadsheet of the LP. If you haven't installed the Solver, I recommend that you watch the previous video where I teach you how to do it. But don't worry, I will leave the link in the description below. The second resource that you need is a copy of the spreadsheet that I'll be using. You can download it on my website, and I will also leave the link in the description below. If you want, you can set up your model on an empty file. However, you may not have the same cell references. After downloading the file and opening it, you see the model that we are going to solve. It's a maximization problem with 4 non-negative decision variables and 3 constraints. Let's start by setting up our model. First of all, our file is divided into decision variables, parameters, objective function, and constraints. Our decision variables are the gray cells. These are the cells that are going to be modified and updated by the solver. That is why we are leaving them empty. Then, we have a table with the parameters. In row 6, we will have the costs. These are the coefficients in the objective function, and they should follow the order of the decision variables: x1, x2, x3, and x4. Type 4 in cell B6, 1 in C6, 1 in D6, and 7 in E6. Observe that the objective function is 4x1 plus 1x2 plus 1x3 plus 7x4. This is the same as the sum product of the decision variables and the coefficients. If you haven't heard about sum product, I made a video with an example, and I will leave the link in the description below. Type equal sum product and open a parenthesis. Then, select the gray cells, which are the decision variables. Press comma, select the light green cells, and close the parenthesis. You should have the following formula: equal sum product B2 colon E2, comma B6 colon E6 parenthesis. Now that we set up the objective function, let's continue entering the parameters. If you look at the LP, you will observe that aside from the non-negativity constraints, we have 3 constraints. Thus, we have 3 rows remaining in the parameters, 1 for each resource. Let's start looking at the first constraint. We have that x1 plus x2 plus x3 plus x4 is less than or equal 20. Type the coefficient of x1, which is 1, in cell B7. Do the same to the other variables: 1 in cell C7, 1 in D7, and 1 in E7. This is the left-hand side of this first constraint. The right-hand side is 20, and we are going to type it on F7, the light pink cell. Let's move to the next constraint, x2 plus x3 greater than or equal 7. Since we don't have x1, we are going to type 0 on cell B8, then 1 in cell C8 and D8, and 0 at E8. The availability is 7 in cell F8. Let me fill in the parameters of the third resource. Alright, now that we have filled the parameters table, we need to type the constraints formulation. As I said, we have 3 constraints, so we are going to be using rows 15, 16, and 17. In this part of the model, we are going to refer to the cells to add the formulas. We are not going to add any value manually. We do that because if we need to change a parameter value, we just update the parameters table and our model will be updated automatically. Go to cell B15. Type equal Select cell B7 and press enter. Do you see that cell B15 now has the value of 1? That's what we want. Let's do the same with the other cells. Click on cell B15. Do you see a small square in the bottom right corner? Click on the square and drag it to the right up to cell E15. See that all the values on constraint 1 were updated. Let's do the same with the other constraints. So drag the square down this time. Voila! All the constraint parameters were updated. Next, we need to create the left-hand side of the constraint. Go to cell G15. The left-hand side of the constraint 1 is 1 times x1 plus 1 times x2 plus 1 times x3 plus 1 times x4. Note that this is the sum product of the decision variables and the coefficients of the constraint. Thus, let's use the sum product function. Type equal, sum product, and open parentheses. Then, select the array of the decision variables, which are the light gray cells. Press F4. You will notice that now you have a $sign in front of B and 2 and E and 2. Type comma and select the array of constraint 1, which is B15 up to E15. Close parentheses and press enter. We did not include the $sign on this other array because we don't want to fix their cells. The value 0 should appear on cell B15. Now click on the green square at the bottom right corner of cell B15 and drag it down. You should have 3 zeros as you see on my screen. The next step is to update the constraint signs. Type less than or equal for the first constraint, greater than or equal to the second, and less than or equal to the last one. Finally, we should refer to the availability of the resources on the right-hand side. At cell I15, type equal F7. A value of 20 should appear. You can either drag down the values on cells E16 and E17 or refer them manually. Cell E16 is equal cell F8 and E17 is equal F9. Alright, we finished the setup, and now we can solve the model. Go to the Data tab at the bar on top and click on Solver. A new window will pop. In the first blank space called Set Objective, you should choose the objective function cell, which is B12, the dark pink cell. Then, choose Max to indicate that we are going to solve a maximization problem. In the space, by changing variable cells, we are going to indicate our decision variables, which are the light gray cells. So select cell B2 up to E2 and press enter. Next, we are going to add our constraints. Press the button Add on the right side. On the cell reference space, at the left-hand side of the first constraint, which is cell G15. Choose the sign less than or equal and select the first constraint's right-hand side, which is I15. Then, press Add. Repeat the process to the other constraints, as you see on your screen. After finishing, press OK. Now, mark the box Make Unconstrained Variables Non-Negative. This replaces the non-negativity constraints. Finally, select Simplex LP as the solving method and press Solve, then OK. Awesome! As you see, the decision variables now have a value and the objective function is 74. I hope this video clarified how you could use Excel Solver. You can access my webpage, luanaalmeida.com, for more content on operations research and Excel Solver. I'll be solving classic OR problems in the next weeks, so stay tuned to the upcoming videos.